Hello and welcome back to Algebra. We are in Chapter 7, Section 1, adding and subtracting polynomials. Alright, first we want to talk about monomials. Monomials, a word that you might recognize in here, is mono, which is 1. Okay, so monomial is a number, like 5, or a variable, like x, or the product of a number and one variable, like 5x, or more variables, like 5x, y, with whole number exponents, like 5x squared, y to the third. All of these are monomials. Notice the only operation between any of them is multiplication. Okay, so that's a monomial. It could be a number, a variable, a number and a variable, or a number and multiple variables with exponents. The degree of a monomial is the sum of the exponents of the variables. So if you have an example like 5x squared y to the third, like we just had, the sum of those exponents of the variables would be 2 and 3. So the degree of this one would be 5. 2 plus 3 gives me a degree of 5 for this monomial. Okay, let's look at a few examples here. So if we have a monomial, just a number, like 10, the degree of that, there are no variables, so the degree of that is 0. If you have the monomial 3x, think about what's the exponent here for 3x. If there's no exponent there, is that a 0 or a 1? Okay, it's a 1, so the degree is 1. If you have a half ab squared, careful with an example like this. This is what they'll like to trick you with on a test. Because you'll look at this and say, well, there's 2 plus nothing else, so the degree would be 2. But careful, when there isn't an exponent, remember that there is a 1 implied. So there's a 1 here, so 2 plus 1 gives me a degree of 3. So careful with those. Those are tricky. All right, and then negative 1.8 m to the 5th power. That's pretty easy because there's just one variable with an exponent, so the degree here is 5. Examples of what's not a monomial. Remember, it can be the product. So if you have the sum of a number and a variable, like 5 plus x, that's not a monomial. And if you have something where you're dividing by a variable like this, 2 over n, if I rewrote this as a product, n would have a negative exponent. You can't divide by a variable for a monomial. Or 4 to the power of a. Okay, that's not a product between these two. That's a power. Or x to the negative 1. Remember, the negative exponent again would imply that you're dividing by a variable. Okay, these are non-examples right here. All right, determining the degree of each monomial. You can pause the video here and try to figure out the degree for each one of these yourself before I do it. So go ahead, hit pause. Okay. A, the degree here is 2. B, remember, here's that tricky situation where we haven't written an exponent, so we have 1 and 3. 1 plus 3 would give me 4. Here, 3 and 3 gives me a degree of 6. And there is no variable here. I could pretend like there's a variable to the 0 power, because that would make it 1 times negative 3. So the degree here is 0. All right, that's monomials. Let's talk about polynomials. So monomials, mono, 1. Polynomials, poly means multiple. So that means we have more than one monomial. So polynomials. A polynomial like this right here, 2x to the third, plus x squared minus 5x plus 12. Notice each one of these is a monomial in itself, but they are combined with addition or subtraction. making this a polynomial. This has 4 terms. Each part of a polynomial is called a term. Each monomial is called a term. So this one has 4 terms, and it's in standard form when the exponents are in descending order. Descending order. All right, so notice here we have 3, then 2, then technically 1 here, and we could pretend like this is an x to the 0 power, right? 3, 2, 1, 0. So the 0 is implied if there's no variable, the 1 is implied if there is a variable. So 3, 2, 1, 0. All right, the first term, once it's in standard form, the first term is called the leading coefficient. And the leading coefficient, this is important, the leading coefficient determines the degree of the polynomial. So here we don't add up all the exponents, only from the leading coefficient, from the leading term. The leading coefficient is just the 2. The leading term determines the degree. The degree of this polynomial would be 3. All right. And then you can have certain polynomials, and we'll be working with these more specifically. So if you have 2 monomials, we call it a binomial. If you have 3, 1, 2, 3, we call it a trinomial. So we'll be looking quite a bit at binomials and trinomials. So binomial has 2 monomial terms, and a trinomial has 3 monomial terms. All right, we want to write this in standard form. So that means we're going to put the highest degree first, so x to the 3rd. And then there is no x squared, so we go to the 15x plus 3. So there's a missing term right here in between the x squared, but that doesn't matter. Now it's in order, so it's in standard form. The degree is 3. And the leading coefficient is -1. Write each polynomial in standard form, identify the degree, and classify each polynomial by the number of terms. All right, so in standard form, that's already in standard form, the degree is 4, and this is a monomial. Okay, this one we need to rearrange. 5x squared minus x plus 4. The degree is 2, and this is a trinomial. Rewrite this, q to the 5th plus 8q. The degree is 5, and this is a binomial. All right, a set of numbers is closed. Okay, this is an important term to know. Closed under an operation if the operation performed on any 2 numbers in the set results in a number that is also in the set. So, for example, whole numbers, the set of whole numbers is closed under addition. That means if you add one whole number to another whole number, you still get a whole number. But whole numbers is not closed under subtraction, because if you take 3 and you subtract another whole number, 4, 3 minus 4, you would get -1, and that's not a whole number. So it's closed under addition, so it's closed under a certain operation. Polynomials, a set of polynomials is closed under addition and subtraction. That means if you add or subtract polynomials, you get another polynomial. All right. Okay, now we want to try to add polynomials. When we're adding, it's pretty easy because we follow all the signs and we can only combine the like terms. So here we have 2x to the 3rd. So I'm going to look for the next highest, and I always start with the highest degree. So there's 1x to the 3rd. That gives me 3x to the 3rd. Okay, next I look at the next lower degree exponent. So here I have negative 5x squared. So look for a like term. There's 2x squared. Now that's positive, so positive and a negative. Add them together, we get negative 3x squared. And then finally, I have just an x, but there's no other x. So plus x, and then the constant always comes last, minus 1. Over here, we're adding these together. Go ahead, pause the video, try to do that yourself. Okay, I'll start again with the greatest exponent first. So here I have 3x squared. I'm going to look for another x squared. It's positive, so that's 1x squared. 3 plus 1 is 4x squared. And then my next smaller exponent is just 1. So 1x to the first plus 4 gives me 5. So plus 5x. And now the constants, negative 6 plus 10 is 4. So that trinomial is my answer. Subtracting is a little bit trickier because the first thing you have to do is basically distributive property with this negative sign. So now that makes this positive, that makes this negative, that makes this positive. Okay, once we've changed all the signs in the parentheses, now we can combine like terms. 4n squared plus, remember we changed that sign, plus 2n squared gives me 6n squared. Then I don't have an n term over here, so I'm going to take this one, and that one got changed, remember, from the plus to minus, so that's negative 2n, and then 5 plus 4 gives me positive 9. So remember, you've got to change all the signs. Pause the video, try this second example by yourself. Remember to change all the signs. Okay. This becomes negative, this becomes positive, and this becomes positive. Now we go through, say that's negative, so that's minus. Now don't say minus minus. We've just applied the negative here, so now we're going to follow all the signs in the parentheses. So it's 4 minus 3, that leaves me with 1x squared. Now we have negative 3x plus 1x. If there's no coefficient, always put a 1 there. Negative 3 plus 1 is negative 2x. And then we have plus 5 and plus 8. Remember, we changed that sign, made that positive. So that's plus 13. So that's the tricky part. When you're subtracting, remember, you change all the signs inside the parentheses, and then you can add them. All right, ladies and gentlemen, that's all for today. Check in again next time for another fun lesson.